Good morning, class, and welcome to this lesson on Geometric Optics 11, the thin lens and magnification equations. Equations. Today we will be able to give the sign for all the variables in the thin lens and magnification equations. So, where do these equations come up from? Well, they come from similar triangles. They come from similar triangles, and I'm just going to show you what they are, but I'm not going to get into the derivation. I'm just going to show you that where it comes from. As you can see here, we have a thin lens, a converging lens, and from that we have a couple sets of similar triangles. We have this triangle right here is similar to this one right here, okay? And then we have this triangle right here is similar to this triangle right here. And as you can see, those are highlighted down below right here. And from that, we derive a couple equations. Like I said, I'm not going to get into the derivation of them, but we get into a thin lens equation and a magnification equation. And the bonus of these equations is that they are the exact same as the equations you learned, the mirror equation and the magnification equation from the mirror section. So we have magnification equals HI over HO, which equals negative DI over DO. So these are the exact same equations. You don't have to memorize anything new. All we have to do is we have to define the terms. And so I just want to point out again that the magnification equation actually can be broken down into some different pieces. It can be M equals HI over HO. It could be M equals negative DI over DO. Or it could be HI over HO equals DI over DO. Okay, so we have this right here is equal to these three right here, okay? So let's define these terms. Focal length. For a lens, F is positive for a converging lens. For a converging lens. Just like it was positive for a concave mirror. Okay? So F is positive for a converging lens. F is negative for a diverging lens. Just like it was for a convex mirror. Okay? So we have a positive focus for a converging lens. Notice that the focus, if we're drawing from left to right, and we're hitting a converging lens, the focus is going to be on the opposite side that the rays are coming in. So this right here, if this is the focus, that would be a positive focus for a converging lens, as opposed to the mirror. The focus was on the same side the rays are coming in. So it's a positive focus on the opposite side for a lens and on the same side for a mirror. Not a big deal, but just want to just clarify that real quick. So next is going to be object distance. DO is going to be positive if the object is to the left, and this is going to be almost every single time. And I'm going to put to the left with like a little asterisk right there. Left being, we almost always in problems, it's just a convention to draw rays coming in from the left, okay? Rays coming in to the left. If for some reason the problem had rays coming in like this, then DO would be positive on the right-hand side. But typically we always draw them coming in from the left. It's just one of those things that has been typical over the years. But so I just want to point that out, okay? And DO is going to be negative if object is to the right, also known as a virtual object. And I'm going to get into this in the next video of lenses in combination. So you can ignore this one for now. That is a very unlikely situation. But so almost always DOs is going to be positive, just like with mirrors, okay? And I'll show you an example of this in the next video. Image distance. DO is positive for a real image, and its DO is negative for a virtual image, which is the exact same as mirrors. Okay? And magnification is going to be positive For a image that is upright with respect to the object, with respect to object, and magnification is going to be negative for an image that is inverted with respect to the object, and which is the exact same for mirrors. So as you can tell, these equations are going to be very similar. If you know mirrors, you know lenses. You just have to know how to plug the numbers in correctly, and that just comes with practice. Okay.